Myself, Ramananda Nayak, selection grade lecturer in Chemical Engineering Department, Karnataka Government Polytechnic, Mangalore. On behalf of collegiate education and technical education, I am going to present fertilizers and pesticide industries in this session. In the last session, we have discussed about acids and alkali industries. We have discussed about the production of various inorganic acids like phosphoric acid by various processes, nitric acid, and hydrochloric acid, their properties, applications, manufacturing process, flow diagrams, all these things we have seen. In the alkali industries, we have seen the production of sodium carbonate, sodium hydroxide, and chlorine along with hydrogen. Sodium carbonate is manufactured by Solvay process and dual process. The process is almost similar, but dual process is slightly modified process of Solvay, wherein the ammonium chloride formed is converted to crystals. It is crystallized, and the crystals are actually used in the fertilizers, that is mixed fertilizers. This session, as I said, I am going to discuss about the fertilizer and pesticide industries. The outcome of this unit on successful completion of the unit 2, the students will be able to identify the applications, the raw materials required, chemical reactions involved, and the manufacturing processes of various fertilizers like urea, ammonium nitrate, ammonium sulfate, ammonium phosphate, pesticides like DDT, BHT, 2,4-D, that is 2,4-dichlorophenolic acid, and parathion. Let us discuss about the fertilizer industries. The fertilizer industry is the major component of the agriculture chemical industry. The production of nitrogen fertilizers should be given the highest national priority. The three major components of chemical fertilizer, that is mixed fertilizer, are: number one, nitrogen. It is required during the early stage of plant growth to promote development of stems and leaves. Second one is phosphorus. It stimulates the early growth of and accelerates the seeding or fruit formation in the later stage of the growth. Third component, potassium. It is necessary to the development of the starches of potatoes and grains, the sugar in the fruits and vegetables, and fibrous materials of plants. Ample supply of potassium in soil sometimes helps to prevent diseases and lessen the effects of excessive nitrogen applications. Potassium, along with nitrogen and phosphorus, is one of the primary nutrients considered essential for the plant growth. In earlier days, the source of potassium was ashes from the burning of wood and plant waste. Let us discuss about the manufacturing of ammonia. Ammonia is the major raw material for the production of nitrogenous fertilizers. So it is more important in the fertilizer industries. Ammonia is manufactured by the reaction between hydrogen and nitrogen. So the raw materials we can list. Number one is hydrogen from synthesis gas. Number two, nitrogen from air synthesis or air liquefaction process. A catalyst is required like iron or iron oxide. So these are the raw materials: hydrogen, nitrogen, and iron oxide. The chemical reaction taking place is nitrogen plus hydrogen. 1 mole of nitrogen and 3 moles of hydrogen gives ammonia, that is NH2 plus 3H2 gives 2NH3. It is a reversible reaction. This reaction takes place in presence of iron or iron oxide catalyst. Let us see the flow diagram for the production of ammonia by synthesis gas. Here, the various equipments required in this are: compressors are required, oil filter, feed guard converter, a reactor, then water chiller, a refrigeration system, circulating pump, separator, and storage. Let us see the process in detail. Ammonia synthesis gas, that is 3 moles of hydrogen and 1 mole of nitrogen. In this ratio, 3 is to 1 ratio, the hydrogen and nitrogen is compressed to the operating pressure of 100 to 1000 atmospheres depending on the required conversion. Filtered filtered this mixture of ammonia, nitrogen and hydrogen gas is filtered to remove the compression oil by passing through high temperature guard converter to convert carbon monoxide and carbon dioxide to methane, and also removes traces of hydrogen, oxygen, etc. The cool gas is fed outside the converter tube wall. Carbon steel thick walled pressure vessels and internal tubes are used. The preheated gas flows inside the tubes containing promoted porous iron catalyst at a temperature of 500 to 600 degrees Celsius. The ammonia thus produced contains 8 to 30% conversion, is removed by condensation, first with water cooling, and then it is refrigerated by using ammonia so that the ammonia gas is condensed into liquid ammonia. The unconverted hydrogen and nitrogen mixture is returned to the reactor to allow 85 to 90% yield of ammonia. Let us see the properties. The molecular weight of ammonia is 17. It is NH3, 1 mole of nitrogen and 3 moles of hydrogen. nitrogen atomic weight is 14 and 3 moles of hydrogen it is 3, total 17 molecular weight. Melting point, ammonia melts at a temperature of minus 77.7 degrees Celsius. It boils at a temperature of minus 33.4 degrees Celsius. Ammonia is very soluble in water. These are the physical properties. Applications of ammonia. Ammonia is used largely in the production of nitrogenous fertilizers like urea, ammonium phosphate, nitric acid, ammonium nitrate, ammonium phosphate, acrylonitrile, etc. These are the properties and applications of ammonia. Next, we will discuss about the production of ammonium nitrate. The reaction of nitric acid and ammonia with the product in this solid form as pellets, crystals, or flakes. The nitric acid and ammonia are reacted and the final product may be made into solid forms of pellets, crystals, or flakes. The raw materials required are 57 to 60% concentrated nitric acid from oxidation absorption tower. Second raw material liquid ammonia, and the inert material is required for final coating of the product ammonium nitrate crystals to avoid explosion. The chemical reactions involved is ammonia plus nitric acid gives ammonium nitrate. This is the flow sheet for the production of ammonium nitrate. Ammonium nitrate is made by two methods. That is, one is by carrying out the reaction in liquid phase, and another one is by carrying the reaction between ammonia and nitric acid in vapor phase. So these are the two methods, that is drilling process, crystallization process, and Stegel process. In drilling process, ammonia vapor is reacted with aqueous nitric acid in stainless steel reaction vessel with proper agitation. Agitation is required for maintaining the uniform concentration of the reactants in the reactor, and also to maintain the uniform temperature in the reactor. The heat of reaction, because it is an exothermic reaction, the heat of reaction causes water to boil off, and the final concentration of the salt in the solution, that is ammonium nitrate, increases to 75% at 140 degrees Celsius. This solution can be evaporated to concentrate up to 95% solid content, that is ammonium nitrate content in that solution. The hot liquor is sprayed from the top of the drilling tower, that is hot concentrated 95% solid content ammonium nitrate solution is sprayed from a sprayer in a tall drilling tower in counter current to the conditioned air which is passed from the bottom. So the droplets which are coming out from the sprayer, when they reach to the bottom, they will get solidified and the solidified prills are about 1.5 mm in diameter and must be screened and dried before coating with clays such as diatomaceous earth or chisel gold to avoid the explosion. Fines and oversized materials after screening are redissolved and neutralized. That is about the prilling process. Next, we will discuss about the crystallization process. It is actually not shown in the flow sheet. Here, the process is similar to prilling process up to the point of spraying. That means up to getting 95% concentrated ammonium nitrate solution. This concentrated ammonium nitrate solution is subjected to vacuum evaporation and vacuum fed to a vacuum crystallizer where crystal growth takes place, and this crystal growth is controlled at about 40 degrees Celsius to yield a large grain required for fertilizer use. Crystal slurry with 40% crystals is centrifuged to separate the crystals from the mother liquor. The mother liquor is returned to the evaporator, reconcentrated, and crystals are, that is, crystals separated by centrifuge. Those crystals are dried in a dryer at 15 degrees Celsius. Dusting with clay 2 to 4% is required to prevent explosion. Dusting means the dust powder of diatomaceous earth or kisel gold is actually used to prevent explosion hazards. Another process is Tegel process. Here ammonia and nitric acid are reacted in vapor phase. The vapors are preheated to 140 to 150 degree Celsius temperature and fed to a packed bed stainless steel reactor, while 60% concentrated nitric acid is preheated to about 95 degrees Celsius and then to 160 degrees Celsius to avoid high temperature nitric acid corrosion. The molten ammonium nitrate thus form and the water vapors at 200 degrees Celsius are passed through cyclone separator to remove steam from the molten salt. The molten salt from the bottom of the solidifier and it is actually solidified on a water cooled stainless steel belt. The solids are crushed, ground, and screened. The ore size is reground and fines are dissolved and reconcentrated and recrystallized, resolidified. The product is finally coated with the inert clay diatomaceous earth or kisel gold and then bagged. So this is the process taking place in the Stegall process in the vapor phase. Next we will discuss the properties of ammonium nitrate. Molecular weight 80, melting point 170 degrees Celsius, boiling point actually it decomposes above the melting point at about 200 degrees Celsius or higher. It is completely soluble in water. These are the physical properties. Applications. It is used in the production of fertilizers, in explosives, and in other chemicals. Now, Let us see some MCQs. Fertilizer value of nitrogenous fertilizer is expressed in terms of its dash content. The options are option A nitrogen, option B potassium nitrate, option C nitrogen dioxide, option D nitric acid. The answer is option A. The catalyst used in the ammonia production is dash. Options are option A nitrogen oxide, option B nickel, option C vanadium pentoxide, option D chromic oxide. Right up answer is option A. Urea is dash fertilizer. Option A nitrogenous fertilizer, option B potassic fertilizer, option C phosphatic fertilizer, option D none of these. Right answer is option A nitrogenous fertilizer. Next, potassic fertilizer is graded on its dash content. Option A potassium chloride KCl, option B K2O potassium oxide, option C KNO3 potassium nitrate, option D potassium sulfate K2SO4. Option B is the right answer. Next question. Rock phosphate constitutes mainly of dash. Option A fluoropatite, option B dicalcium phosphate, option C monocalcium phosphate, option D diammonium phosphate. The right answer is option A fluoropatite. Thank you.